Hey everybody, this is section 5.81, applications of exponential and log functions. Today we're going to focus on the exponential, and then in day 2 we'll focus on the log. But let's start off with this word problem, and you've got all the givens, and so the way they translate in knowns and unknowns is that you start with the principal of 100,000. The interest rate is 8%, don't forget to write it as a decimal, and so you can plug it into this formula. The principal goes here, the 8% goes here, and then we're looking for, we don't know what time is, but the amount in your bank account, the final amount, is a function of time. You might think, now, why does this formula work? It's because you start with the principal, and every year you multiply it by 1.08. If you just multiplied it by 1, it wouldn't stay anywhere, but because you multiply it by an amount that's a little bit more than 1, then you're going to increase it, and you increase it 3 times. That's like if there were 3 here for 3 years, then this factor here would be written out 3 times, and that's why the formula works. And there it is. Little bonus for you. So part B, they ask why is you know that the final amount is 500,000, what you don't know is the time. So you can set it up like this: final amount is 500,000, and if you start with 100,000 and you're increasing it by 1.8 every 2 years, then what would that look like? You can divide both sides by 100,000 and get 5. And so 5 equals all of this. And there's 2 ways of thinking about it. First of all, you could take the log of both sides. So you get log 5 equals log of 1.08t. And then knowing that an exponent on the inside becomes multiplication on the outside, as t goes over to the outside, and so that you have log 5 equals t times log 108. Dividing both sides by log 108, you get this, and then plugging all that into the calculator, you get this. T is about 20.9 years. A second method to do this would be to change it to a logarithmic equation. Here's the exponential form. Here's a logarithmic form. We've got a base, an exponent, and a power. So here's the base, the exponent, and the power. Anyway, most calculators, there's a lot of calculators that can handle strange bases like 1.08. Desmos can do it. The high-end Texas Instruments can do it. But if you find yourself unable to type this in and hit enter, what you can do is use the change of base formula, which actually perfectly leads you to this: log base 10 of 5 divided by log base 10 of 1.08. And you divide, either way, if you type this into your calculator here, or this fraction into your calculator here, you will get the same number, and that's 20.9 years. Now, I would note that if you knew that you wanted to multiply, like get to 5 times the original amount, one thing you could do is jump straight to this. Like, let's say the given wasn't, the known that they gave you in the program wasn't 500,000, but instead just 5 times the original amount. What you'd have to do is say like a equals p times 1.08, and then divide both sides by this 100,000 that you didn't know, the p over here, and you get 5. How long, if the question were how long would it take to get 5 times your original amount, you'd have to start right here. You'd have to skip this initial first step and just say 5 equals all this, and at which point you would get here. So the actual original amount doesn't matter if you knew by how many times you would need to go. You would the 20.9, nowhere in the calculation, nowhere do you type in your calculator ever the numbers 100,000 or 500,000. What you need to know is by how many times you're increasing. So part C actually asks you how long. What is unknown is the little amount of time when the amount gets doubled. Big T is called the doubling time. Big T is 2. So this is an amount of time that you would have in order to double your investment. And there's no units on this. This is just the number 2. Like, you want twice as much money. Now, what you could do is you could say P is equal to 100,000, and so therefore double that is A equal to 200,000. And you could plug that in right here. 200,000 equals 100,000 times 1.08t. But that's actually not necessary. and it's extra information. And often on the SATs, ACTs, a trick is to not give you this information and just say, if you wanted to double, they give you the original thing, like the original formula, and then they'd say, well, how long would it take to double your amount? Not even knowing that it's 100,000. And so you wouldn't be able to plug in these two. You would have to just first, as a first step, divide both sides by this to get A over P equals 2. Technically, you could start right here at this step. Doubling time 2 equals 1.08 to the t. And you solve it the exact same way that we did the previous work over here. The way that I did it is that I just took the log of both sides. And so if you're going to take the log of both sides, then you get this. You bring the t over to the front, and then you divide both sides by 1.08. You tell me what that is here. I've like yellowed out something. So you tell me what number should be here if you've been following along. Anyway, when you plug all this into your calculator, you get 9.01 years. The doubling time is 9.01 years, and it's not as a result of the amount of money that you put in, but it's purely a result of the investment rate that you get, the interest rate. So that kind of leads us to a formula. If you want to know, if you're given this kind of formula here, this kind of compounded annually interest formula, then the doubling time is not a result of the original amount that you have, but purely amount of, like, the doubling time t is log 2 for doubling over log of your interest rate, 1 plus I. And that's kind of a formula you can use. Anyway, that's what we're looking at here. I just wanted to say that my kids are huge fans of chicken nuggets. That's what they've been eating. You all went through a phase where you ate nothing but chicken nuggets too, I'm sure. Or if you have a favorite food from your childhood, then go ahead and let me know. But that's your audio check for today, and I'll see you in class.